We are the multi-UAV simulator team here at the Grill. I'm going to start off with some brief introductions of who we are. So my name is Ashton Tucker. I graduated from Oakwood High School this last spring, and I will be attending the University of Michigan in a couple weeks to study aerospace engineering.
My name is Akhilesh Prasad, and I graduated from Beaver Creek High School in May, and I'll be attending Purdue University to major in mechanical engineering.
My name's Sid Verma, and I'll be a rising senior at Centerville High School, and my intended major is industrial engineering, finance, or statistics, or some combination of the three.
So now that we've all introduced ourselves, I'm going to provide a brief overview of our presentation today before we introduce our challenge problem. So first, we're going to go over the objectives and the challenge problem that we were given for the last 6 weeks. Then we'll dive into our individual roles and how we each tackled a different aspect of our challenge problem. Akhilesh is going to start with game logic and user interface. Sid is going to cover the 3D environment, and I will finish up with the data input and output of the simulation. Then we'll introduce our final deliverable, and we'll open up the floor to any and all questions.
So we've been working with Dr. Summer Rubensky from the Atlas Lab at Florida Tech University for the past 6 weeks. And basically, we've been developing a simulation which will be used in the future to conduct studies about human agent team studies. And basically, the different levels of drone automations will be used to assess different factors such as trust in teammates, team effectiveness, and trust in machine teammates. So basically, the challenge problem that we're given this year was to design a simulation where the user will be able to control 4 drones in a first-person camera view, and essentially these drones will be flying on pre-programmed paths throughout the whole game. But whenever the user wishes, they can take manual control of the drone and fly it wherever they wish to. So basically, when the UAV is on the pre-programmed path, it will detect objects, and it'll alert the user about this, and then the user has an option to enter in their own personal input on whether they spotted this object or not. And then basically all this data will be recorded and exported to like a spreadsheet file at the end. And after the whole simulation is over, there are integrated NASA TLX surveys which will ask the user's opinion about like the physical and mental demand of the simulation, and this will be used in further studies.
So the creation of our multi-UAV simulator primarily involved the utilization of 3 different resources. The resource that we used for the majority of our project was Unreal Engine 4, which is an open source game development software. And we ended up using Unreal Engine in the user interface of our project, the input-output, and the 3D environment. Another resource we used was Blender, and this was used in many of the pre-built assets that we used in our 3D environment for our UAV simulation. And finally, we used another resource, which was Quixel's Megascans asset library, which is a tool that allows you to export real-world images and like textures into your project like directly, and it allows us to directly export several different resources into our 3D environment.
So basically, I handled the user interface and game logic. So there are 2 ways we could have gone about doing this. We could have used C++ line-based coding, or we could have used Blueprint block-based coding, and we decided to use Blueprint because it's much easier for people with lesser programming experience. And one big task for the user interface was to display the UAV data variables such as like the speed, altitude, location, and other things like that. This would have to be printed to the screen so the user can see it all the time. And then the second big function was creating a way for the user to toggle between manual control and auto flight so that they can switch whenever they want to. And the third big function was the satellite view, where the user can switch from the first person camera view to a full top view of the whole map, and they can drop waypoints and navigate through the map in a much easier way. And basically, we designed the game logic in such a way that it's easier for future researchers to easily change the variables according to their new requirements that they have in the future. So basically, initially we didn't have access to the realistic drone plugin, and so we created the logic and we applied it to a simple moving cube. And then once we purchased the UAV drone plugin from Epic Games Marketplace, we were able to take the logic and simply transfer it over to the drone. But it actually wasn't as straightforward as it was because there was a lot more applied physics to the drone, and we had to account for that, such as like the rotation of the propellers and things like that. So we had to make a lot of edits to our logic while transferring from the cube to the drone.
So I was responsible for the creation of the 3D environment. So Dr. Rubensky from Florida Tech actually wanted like a 3D like desert-based environment that like reminded her of like the Middle East, like a Middle Eastern-based environment. And like some of the goals for this environment were to include like some native architecture, native foliage, make it really look like a Middle Eastern-based environment. And that like caused me to like I had to do some research. I found out about I was able to like find and import like acacia trees and like many local foliage and things from that region. And the importance of making like including these real aspects like and this environment were to provide distractors for the user. And so while the user is operating the UAVs, they're distractors in the environment. And another big thing was to have like a an aspect of realism in the 3D environment. And this aspect of realism was to make it more immersed so the researchers can actually do further research as the environment would be more realistic and they would be able to almost like uh, act as if it's research in the real world. Next slide. One of the initial issues I had while creating the 3D environment was implementing actual realism and trying to make the 3D environment look as real as possible. And I resolved this by actually utilizing an asset library called Quixel Megascans and Quixel Bridge. And this allowed me to like import high resolution textures and assets into the project directly, as Quixel Bridge is like an integration which you can add between Unreal Engine, which allows you to directly import 3D assets and stuff into your project. And this allowed me to use like 2K resolution images. And this software also allowed me to make realistic textures and made our environment a lot more immersive. And part of the learning experience for making the 3D environment was it allowed me to learn from a lot of the industry professionals involved in gaming. And I was able to actually watch them create like something from nothing. And it really showed you all that's capable when using software such as Unreal, Blender, and all these other tools.
I helped out with part of the 3D environment by making all the objects. There are 8 different soldiers and 6 different tanks, I believe, or vehicles that the user can drop into the scene in order to detect by the drones. So our researcher at Florida Tech wanted a green shirt, red shirt type variable where the drones can detect either a hostile or a friendly object inside the world. So as Akilish was explaining earlier, our drones fly on pre-programmed flight paths, and when they invisibly collide with one of these objects, it displays a widget where the user has to identify whether that the object the drone has seen is a friendly or a hostile. So I had to do a lot of the user recognition and import and decide a lot of the accuracy statistics that go along with these detectable objects. Next slide, please. Along with the 3D environment, I did all of the data input and output for this simulation. So that starts with analyzing a lot of the user dropped pins and a lot of the accuracy statistics that go along with that. With the satellite view overlay that we have, the user can drop a pin at any time that identifies what kind of object they saw within the scene. There's red pins and green pins, and I had to analyze whether the user was correct in that and export data statistics to go along with that. In addition to the user dropped pins, I also did a NASA TLX survey, which is a mental demand type survey that you can see on the right side of your screen. There are different types of questions that analyze a user's mental demand or how hurried or rushed they felt throughout the pace of the simulation. And a lot of this has to do with what our researcher wanted in order to analyze how efficient someone can be with the amount of detectable objects there are in the simulation, or the amount of drones that they're handling the entire time. Next slide, please. So you can see on your right a lot of the data that goes along with that. I also analyzed the possession of each of the drones. As previously mentioned, the drones can be manually controlled or set back on their flight paths at any point in time, and I was to record those timestamps along with the timestamps as of all of the other detections in order to analyze how effective someone can be in training with their machine teammates. So a lot of that had to do with promoting the future research of this could be applied to search and rescue missions or just UAV training in general. Along with this, we have a short video of our Sorry about that. As you can see, this is part of the satellite overview. Along with that, the drone's flight paths are tracked throughout the simulation, as well as any tracking that occurs within manual possession. As you can see, there's 4 different flight cams that go on simultaneously, and they all track these different objects within our scene. That's a brief example of what a drone would display to the user when they collide with a possible friendly or enemy object. So our final deliverable that we presented to our client at the end of these 7 weeks was a fully functional simulation with 4 completely independent UAVs on a completely custom environment. So it has fully functional friendly and enemy recognition, as well as all of the statistics that are exported after that. All of our variables are easily accessible in order for our researcher to change that even after we leave. So in conclusion, next slide please. We'd like to thank the following people for allowing us to be here today and to work on this amazing challenge problem. First, we'd like to thank Dr. Wink Bennett and Lieutenant Dave Clement for their facility and program management. Second, we'd like to thank Jack Hugh, our mentor, for all of his help and advice. Third, we'd like to thank Dr. Summer Rubensky for presenting this challenge problem for us. And finally, we'd like to thank Mrs. Debbie Miller for organizing the Wright Scholar Program. This concludes our briefing. Are there any questions?
Great. Any questions for the multi-UAV team? Ashton, had any of you used Unreal Engine or Blender before this internship?
No, none of us have used Unreal before, and none of us really had that much programming experience to begin with. So we all kind of agreed that that was our big takeaway from this experience, that we all learned a lot of programming and a lot of use of texturing and 3D modeling.
Yes, you really impressed me with your knowledge in 6 short weeks. It's a great presentation. Thank you.
Thank you.